Welcome everybody to this video about the last principle of Solid, which is no other than the Dependency Inversion Principle, or in short, DIP. The definition consists of two parts. That's why I have also put it here so that you can also read it as I'm reading it to you. The definition is a little bit confusing, but the explanation shows that it's something really simple. So it says that high-level modules should not depend on low-level modules. Both should depend on abstractions. And secondly, it says that abstractions should not depend on details, but details should depend on abstractions. In essence, what this says is that the provided dependencies to our classes should contain interfaces and abstract classes instead of concrete class and functions. Again, as always, on the left, we have the code that violates our principle, in this case, the dependency inversion one. And on the right, we will use the same code as a starter code, and we will build through our solution in order to fix that violation. And again, you can always compare the left side with the right side as we write our code. So in our example here, we pass a concretion, okay, rather than an abstraction. We have a payment processor that takes some payment method, okay? And our payment method that we pass is directly the implementation for a PayPal payment. But let's say we want to add some more payment gateways, like Stripe, for example. Well, actually, our payment processor right now accepts only PayPal payments. So, what should we do? As we said, we should pass abstractions. So, interfaces come again to the rescue for us here. So, the solution would be simply to create an interface for our payment. And let's say that we have an interface and we call it payment. Okay, this interface should define a pay function, just like this one. So, given that, the only thing we now need to do is have our PayPal payment implement that payment interface. And we should also put the override keyword so that we are actually implementing our function that is defined on that interface. And as simple as that, we have a PayPal payment that implements the payment interface. So let's create also the Stripe payment, okay? We just take a copy. Let's rename this to Stripe. And let's change our implementation so that it's a Stripe implementation, okay? So here now, in our payment processor, instead of having a PayPal payment, let's create a payment method. Better, let's rename this to payment method. Okay. So instead of passing as a payment method the PayPal payment, we will just pass a payment. We don't know what kind of payment. We will pass a payment. Now here we are already done because we're passing a PayPal payment, which is a payment. So we are already done for this. But let's also create another payment processor. But this time I call it payment processor 2. And this time our payment processor 2, instead of using a PayPal payment, instead it will use Stripe payment. And just like that, our payment processor now can take two different implementations of the payment interface, of the payment abstraction, and use it. And that, together with the first principle that we defined in Solid, those two are actually the two most important principles. This is a very important one because it promotes modularizing our code, and each part of the code be independent of the other, and that's possible only through abstractions. Now let's run this code, and as you will see here, as expected, our payment processor, the two instances of our payment processor are utilized with a different payment method. In the first one, we have a PayPal payment of 100 euros, and in the second case, we have a Stripe payment of 200 euros. So I hope this was a little bit insightful for you generally. If you liked this video series, please thumb up and subscribe.